Hi there, this is Jiru Munduluru and welcome back. We know that Java is an object-oriented programming language. And if you recollect from the previous section, we also said that an object-oriented programming language helps model real-world scenarios in a more natural way. And it does so with the help of objects and classes. And object-oriented programming, as its name suggests, is all about objects. And an object is created from a class. And in the last section, we looked at the Hello World class. Both classes and objects are the most fundamental units in an object-oriented programming language. In this lecture, we will first understand class and objects at a conceptual level. That is how they represent real-world scenarios. And then we will see how they are represented in a Java program. Object-oriented programming, which in short is often referred to as OOP, traces its roots back to 1960s. So it's a very old programming paradigm. And it was conceived to implement large complex projects in a simple way. And by that we mean they help model real-world scenarios in a more natural way. So that's the main benefit of object-oriented programming. Let's take a look at a few real-world examples. One example is a student registering in a particular course which is offered by a particular department. Another example would be a customer buying a product. Similarly, we can have a doctor treating a patient. And all these examples can be more naturally modeled or represented in an object-oriented environment. So let's see how that is possible, and let's pick the first example here. So here we have three entities: student, course, and department. Here, a student would have some data associated with him or her and can also have some behavior associated. Data would be things like student name, student age, gender, address, and so on. And behavior would be actions like registering for a course or updating one's profile information. Similarly, course and department would also be associated with some data and some behavior. And here is an instance where we have a student named John and we have 4 courses and 2 departments, computer science and civil. So here we have some instances with data being just the name, like John or Java or computer science. And we can have these 4 courses offered by the CS department. And John can register in these 3 courses. So that's some behavior or actions happening between these instances. So this is a realistic scenario where the student John has registered in 3 courses which are offered by the CS department. So an instance like John can be visualized in this way, where data apart from name would also include other things like student ID, gender, and courses that John has registered in. Similarly, John can also perform the 2 actions, registering for a course and updating his profile information. In an object-oriented environment, this data that John's instance can have is generally referred to as state of the instance, while these actions as just behavior. And this whole instance of John is referred to as an object. So the student John is represented by this object, and similarly we can have other students represented by other objects which are unique to those students. So an object has both state and behavior, and these objects cannot exist by themselves. There should be some sort of a specification that tells the data that objects can have, like ID, name, gender, and so on. And also behavior like course registration and update profile. And that specification is the class. So class is like a blueprint and objects are actual instances of the class. In fact, often the term instance is also used to refer to object. Here is an illustration of relation between a class and its objects. At the top, we have the student class defining the state and behavior that its objects can have. State includes student information such as ID, name, and gender, and there is only one behavior defined which allows the student objects to update their profile information. Now for the sake of simplicity, course related stuff like the courses registered by a student has been omitted from this illustration. And we can also see the 3 student objects in ellipticals, and these are created from the student class. Each student object has its own state. For example, first student's name is John, who is a male and has a student ID of 1000. Similarly, second student's name is Raj, who is also a male and has an ID of 1001. Third student's name is Anita, who is a female and has an ID of 1002. And the behavior update profile would be associated with all 3 objects. That is, it is common to all 3 of them. Now in the student class, update profile would be a method. So methods define the behavior. And in the last section, we have seen the main method in the Hello World class. And object state is defined by variables. Variables and methods in a class are considered as members of the class. And later in the section, we will learn about both variables as well as methods. Now, apart from variables and methods, a class can also have other less commonly used members such as nested classes and nested interfaces, which will be discussed much later in the second half of the course. So when someone refers to class members, they are normally referring to either variables or methods. So that's about it. Conceptually, that's all there is to class and its objects. Now let's look at how they are represented in code. And we are going to use the same student class example. But for now, let's not worry about writing the code. Our goal for now is to just get a feel for how to create an object from a class in Java. And that we will see in the next slide. So here is the definition of student class. It is first declaring the variables which would represent the state that student objects can have. So we have ID, name and gender. And variables are like containers as they hold some data. And each variable is also associated with something called a data type, which tells what type of data the variable can hold. For instance, ID is declared as an int, and int means integer, which means that ID can hold integers like 1000, 1001 and so on. Similarly, name and gender are declared with the data type string, and string implies that the variables can hold textual data like Anita for name and female for gender. Int data type will be discussed later in this section, while string will be discussed in one of the subsequent sections. Next, the student class also defines the method updateProfile, which simply updates the existing name with a new name. And the new name is passed as input to the method. And method parameter represents the input. In this case, it has the name new name and is of type string. Method parameter is also a variable just like ID or name. And in the body of the method, the variable name is assigned with the value of the method parameter new name. Equal to is the assignment operator, and it just assigns the value on the right to the variable on the left. Methods will also be discussed later in this section. So that's the student class. Next, let's see how we can create a student object and then initialize its state. And we will also see how the students only method updateProfile can be executed. And for that, we will use a new class called studentTest, and let's assume that the code is written in this main method of the class. So first step is to create a student object, and this is how it is done. You would use the keyword new, which would be followed by the keyword student, as we want to create an object of the student, which is in turn followed by parenthesis. So new followed by student followed by parenthesis would create a student object, which is then assigned to a variable called s, whose data type is student, which indicates that s would hold a student object. So it is similar to the way we declared the variable ID in the student class. With ID, the data type was int, indicating that it would store an integer value. So we created a student object named s. Next, we need to initialize its state. That is, we need to set the values for the variables ID, name and gender that the student class has declared. And for that we use the dot operator. That is, we would have the object name as followed by dot followed by variable name, which here is ID, and then we assign it with a value, which is 1000 in this case. To set name, we have s followed by dot followed by the variable name, and it is assigned with the value Joanne. Similarly, gender is assigned with male. Here we have double quotes enclosing Joanne and male, but not for the ID value 1000, and that's because Joanne and male are strings, and in Java for strings we need to use double quotes. So the student object s now has a state. However, here let's assume that the name was misspelled as Joanne instead of John, and so we need to fix it. And for that we need to execute the update profile method and pass it the correct name John as input, and the method would then update the name variable with the new name John. So to execute update profile method, we once again use the dot operator. That is, object name as is followed by dot, which is followed by update profile, and we are passing John as input to the method. Here we say that we are invoking or calling the update profile method on the object s. So that's how we create an object, initialize it with state, and invoke its methods. Actually, to initialize object state, it is normally done using something called constructors, but they will be discussed later in the section. So doing it the way we see here is not done in professional projects, but this is just for us to get started for initializing the state. Also note that in a real object-oriented software, you would have tons of objects communicating with each other. And the way one object communicates with other is by invoking a method of the object and passing any necessary data as input. So that's about it. I hope you now understand what a class and object is, how they represent real-world entities like student, and how they can be created in Java. Thank you and see you in the next lecture.